Hello guys and welcome back. In this chapter we're going to learn basic soft data lake architecture in the perspective of AWS serverless data lake analytics. So let's get started. Firstly, let's try to see what the actual scenario is. We have lots of documents and file-based data sources coming in every day. If you're working in an IT environment, then you see an ecosystem of a lot of equal data sources like mobile app data, infrastructure, logs, or social media data, or Excel spreadsheets, or any other kinds of spreadsheets, as well as clickstream data. These are some of the examples. For clickstream data example, let's say on a website, whenever a user is clicking or using their mouse, hovering their mouse, or where they stop, this is all considered clickstream data. This is continuously captured by a lot of websites, and based on this websites, they analyze what is the purpose of the user, or where are the users turning more, and they try to gauge an idea of what is popular on their website and what is working and what isn't. So these are the kind of data sources that are within documents and files. In terms of records, we have things like Amazon Relational Data Services, RDS. We have DynamoDB, which is a key value per NoSQL kind of database. Amazon Redshift, which is a petabyte data warehouse. We have on-premises databases such as SQL Server, Oracle, Teradata, lots of other database sources. Then there are ERP-based data sources like SAP, which also generates a lot of data. Other type of data are streams. So you have a lot of devices that are connected these days, and these devices like sensors are, or a lot of electronic devices are continuously sending information. A simple example is when you go to any office, you will see a card, let's say for swipe in, swipe out into the office. In that way, there is a lot of different transactional or IoT systems which are generating a lot of data. Then there are device data, which, as we discussed, then there are sensor data, like all the security cameras, which are capturing feeds continuously. And there are different technologies within the AWS which can read, analyze those kind of streams continuously. And then we have such things as Kinesis streams and Kinesis Firehose, which are AWS services, which are ingesting data continuously in a stream forward. So the general idea that is represented here in this picture is that there are multiple data sources, and all of them have different kind of data environments, and they are growing every day. So in general, there are literally an explosion of data nowadays coming in from every different sources around. So you might have heard of data warehouses. Now here we are also talking about data lakes. So before we even go to discuss data lakes, one should know what is a data warehouse. So if you do not know what a data warehouse is, let me summarize it in a very simple manner. The way you should understand what a data warehouse is an organization whereby there is a single centralized repository of data where all your data lies based on a schematic structure. Based on that data house, you take slices of data which is correlated and makes some sense, such as HR data, finance data, product data, and these are all could be thought of as data marts. So if that's what a data house is, what is a data lake and what are the differences? That is very important for us to understand, because all the architecture diagrams that we are going to see in the subsequent chapters will be based on that. So here are some of the differences. Within data lake, you will have semi-structured, unstructured, and structured data. All these kinds of data can be found in data lakes. Generally, data warehouses contain only structured data. All the data that you might have in your Oracle or SQL Server, Postgres, are usually structured data and has been brought together. The unstructured data in the form of files or spreadsheets or sensors, IoT data, that is generally unstructured data and is stored in a data lake, and it does not qualify in a data warehouse. A dimensional model for a data warehouse generally is a star or constellation data model, which you generally normalize in a data warehouse for aggregation. Yeah, so here within the data lake, the schema is usually on read, while within the data warehouse, the schema is usually on write. The difference is that within data warehouse, the schema is already there. When you populate the data warehouse, you already have the data there. Within the data lake, you take all that data and you put it into a central repository where the schema depends on when you want to read, and you do not usually create a model within the data lake. You just take the data as in and store it together. For data lakes, you'll be able to use data science for predictive analysis, for BI use cases, while in data warehousing, you would more be focused on SQL-based BI use cases. It's for data lake, you have great for storing granular data or raw as well as process data. With data warehouse, you would actually do a lot of refining and aggregation and frequently accessed data. That is for the data warehouse. So mostly data warehouses and marts are used for analytics use cases where data is cleaned and cleaned and processed in an ETL process, and then you'll be able to do frequent access and aggregation summation of that data. Finally, this issue of separation and computing storage is a very important point. And it's probably the second most important point after being able to differentiate between semi-structured and unstructured data. In data lakes, you try to separate compute from storage data, and we'll see that in following chapter. And keep this in mind as we go through this presentation and following chapters. In the data warehouse, there are, for example, in data redshifts such as Redlift, this is tightly coupled, and you have these clusters which are built on the data warehouse, and all these nodes have a different hardware, and on those you store the data. So storage and compute, or the processing power, is on the same machine, and it's not decoupled on the data warehouse. But here in the data lake, you try to store it, let's say, on an S3 bucket or some other appropriate storage, which acts as your central data repository. But the compute depends on what tool you would want to use for analysis. So let's say, for example, using Athena, which is based on Presto. So that is what you will use for analysis. Now, data lake extends traditional warehouses. So this diagram may make it easier for you to understand how data warehousing and data lake extend. As you can see over here, we have the front-end tools. Then here we have the different varieties of data, or let's say consumers. And here you have the data warehouse. So whether you have a transactional system, an ERP system, CRM system, line of business systems. And then there is a data lake, which brings in more of the data from the various pipelines. And data lake would use data warehouse as one of the data repositories. So Here you would see that it's relational and non-relational data, terabyte to expanded schema defined during analysis. So that is a schema on read for data lakes, and diverse analytic engines to gain insights. As you can see, you have machine learning, and later on you would have many other query engines, and we'll look at that in the later part of the course. And then finally we have design for low-cost storage and analytics. So data warehouse, you may store such as tend to be more economic depending on how large you cluster. But if you have data which is streaming data or raw data, you do not need to do a lot of ETL to convert it into a relational model and put it there. So that's where the cost comes in. You can store the data in its original format, and still you can make use of that data. That is the beauty of a data lake. And we are going to see how to. Moving on, these are the different layers of a data lake service. You have the data sources, you have the ingestion of the data, then you prepare the data, and then you organize the data. Organization means you go on to secure and implement that type of governance on it. You implement a taxonomy on it if required. Then you discover the data, and finally you let the users use it. This slide will be of interest to architects, because generally they would want these kind of slides to explain to your senior leadership what you're going to do. But if you're just doing it for yourself and you're not in that kind of job role, then you can just take the slide as just help. This is the architectural view of a data lake from an AWS perspective. So in our perspective of this course, we will be using Amazon S3 as the storage. For security, we have all these different services available, such as KMS for encryption. For analysis, we have Athena, which we are going to learn, and we have Amazon Redshift Spectrum. We will be focusing on Amazon Redshift Spectrum on this course, and not Amazon Redshift itself as a data warehouse, which is a very large topic. This is a more simplified architecture view of what we're looking at. So if you have been confused by the other diagrams, please don't be just look at this one. This is the final diagram. This is the one where we will try to understand what we're trying to use. So AWS Glue we'll be using to build a catalog. We're going to be using the S3 bucket Amazon for the storage. We're going to be using Redshift Spectrum for analysis. And we're also going to use Athena for analysis. We'll be using QuickSight for reporting, and we're also going to look at an example of how to use Zeppelin, Apache Zeppelin also. So these are the ones we are going to focus on in this course. But if you want to understand the full ecosystem of how data goes from source to service, then this is the view of the service. All the transactional data. Let's say you bring in from the front mechanisms to the S3 bucket. This simple could be just a file, a normal file, but you could use all the different services available to upload data to the S3 bucket. And after that, you will build a catalog. And when the catalog is ready, you could do transformations on it, or ETL, or whatever you want to do on it. Once that is ready and done, then you could take the query engine data. You could use either Athena or Redshift Spectrum, and we'll be covering both, and then we can report on that using QuickSight. So we have S3, Glue, Athena, Redshift Spectrum, QuickSight. All of them are serverless. So how can you interpret data lake and data warehouse? So that is where Redshift Spectrum would come into the picture, because Redshift Spectrum can query data from Redshift clusters, as well as it can query the data from S3. And that can bring a mix of how you can correlate data. So here you have the Glue ETL, then you have the Redshift, and then you have the AWS Glue crawlers, then you have the Glue catalog. Data is stored in the S3, which is read by the Glue. And then once it is there, you can load the data into Redshift, or you can even load it directly without ETL. And then the crawlers will move on to the catalog. And once the catalog is there, it could be used by services such as Athena, Redshift, QuickSight, Azure. We're going to learn this step by step, and we have a lot of material to cover, so do not worry if you don't understand right now. We're going to go through this slowly. We are just getting started, and this is just an overview of the architect. Take your time and take a breath. So finally, this is a sample diagram that you may see in a lot of the discussions on the web. These are some of the diagrams that you'll see in the data lake analytics training from AWS itself, or on the web, where you have a lot of integration points. I just wanted to give you a slice of what we are going to do, so that in the future, after taking this course, if you go ahead and look at these kind of diagrams, you will be able to understand this. So some of the points you can quickly take from these kind of complex diagrams is that S3 is the central storage for data lakes. You will have QuickSight for the reporting, which is one of the reporting tools. You will have Glue for clusterless ETL. It's a serverless ETL service. And then you will have Amazon Redshift Spectrum for all your analysis, based on if you want to do analysis from Redshift, and if you want to join together. And if you want to do analysis solely on the data sitting on S3, then you would be looking solely with Athena, which is another serverless service. So that was all I wanted to show you guys today. And I hope to see you again in the next video. Thank you very much.